Hello, I'm Mike Battaglia, a research forester at the U.S. Forest Service Rocky Mountain Research Station in Fort Collins, Colorado. Today, I'd like to discuss some of the research we are doing in Colorado examining tree regeneration in post-spruce beetle impacted forests that have been salvage logged. First, I'd like to acknowledge my collaborators on this research, Jason Seibold at Colorado State University, and Kevin Barrett and Tony Chang at Colorado Forest Restoration Institute at Colorado State University. Over the past couple of decades, the spruce bark beetle has impacted about 1.9 million acres in Colorado's subalpine forests. These beetles have resulted in large expanses of dead Engelmann spruce trees across the landscape. Because much of the beetle kill is within the suitable timber base of public lands, salvage logging is taking place to recover the wood. These activities have led to an increased concern by local stakeholders about the impacts of salvage logging. To address these concerns, we set up a research project intended to compare areas that had never been harvested, such as in the wilderness areas that were harvested in the late 1980s and early 1990s with shelter wood prep cuts, and areas that were recently salvaged. We are measuring a whole host of variables, but for this presentation, I will only focus on tree mortality, stand structure, tree regeneration, and seed production. Our research study area is within the Gunnison National Forest in South Central Colorado. We set up plots across the forest in spruce-dominated stands and spruce-aspen mixed stands. Currently, most of our work has been in spruce-dominated stands, but we are working to get more installed in the spruce-aspen mixed stands. So let's start with the spruce-dominated stands and see what we found. Now, these two graphs on this slide here show that basal area and trees per acre for the unharvested and previously harvested stands before the spruce bark beetle and after the spruce bark beetle outbreak. In terms of basal area, we observed between 94 to 97% mortality in both the unharvested and previously harvested stands, leaving about 5 to 10 square feet per acre of live trees. On a tree area per acre basis, tree mortality was about 70% in the unharvested areas and 61% in the previous harvested area, leaving about 200 to 300 trees per acre not impacted. Now, when we look at the diameter distribution of pre and post beetle outbreak in the unharvested stands, we observed that the beetles killed all trees greater than 4 inches in diameter and some of the smaller diameter size classes. Examination of the diameter distribution of previously harvested stands shows a similar pattern. All trees greater than 4 inches in diameter were killed, as well as some of the other smaller diameter trees. Now, when we look at the structural outcomes after salvage, we see a further reduction in live basal area and trees per acre, with only about 3 square feet per acre of live trees, as shown in the yellow, and 83 trees per acre. Now, when we break this down by species, we see that the unharvested stands are dominated by a mix of spruce and aspen. Previously harvested stands are dominated mostly by spruce with some alpine fir. And salvaged areas are dominated by spruce and some aspen. And as a reminder, most of these trees are in the salvage or are in the sapling sized size classes. Looking at the regeneration species composition does provide some good news, however. So when we look at regeneration, we broke it down into spruce that had regenerated within the last 5 years, spruce that was greater than 5 years old, subalpine fir, and aspen. And here we can see that all Engelmann spruce is regenerating very well with densities that exceed minimum stocking requirements. The unharvested areas had a mix of spruce that regenerated within the past 5 years of the outbreak and before the outbreak. Most of the previously harvested stands had spruce that regenerated before the outbreak, but after the shelterwood prep cuts in the 1990s. The salvage areas had some recent spruce regeneration, but mostly it was dominated by advanced regeneration that was not impacted by the spruce beetle or harvesting machines. We also observed some aspen regeneration in the unharvested and salvaged areas. Now, a major concern about the regeneration is that much of it would be coal and would not respond to the reduction in the overstory. Our surveys indicated that about 14 to 20% of the regeneration for spruce was coal, and 10 to 24% was coal for the subalpine fir. Now, to measure tree regeneration and sapling growth post-beetle and post-salvage, we have tagged a substantial number of trees that we will remeasure in the next several years. So stay tuned for that data. We were also interested in understanding if the reduction in mature trees would impact seed production and future spruce recruitment. So to test that, we set out seed traps for 3 years to measure seed production. And a few things I want to highlight. Each of these bars on the graph represent an individual year from 2018 to 2020. And we observed that seed production was quite variable year to year. However, within a year, seed production was similar among the different treatments, indicating that there was still some seed source close by. Now I'd like to switch gears and discuss what's happening in the spruce-aspen mixed areas. In many places, aspen and spruce grade into each other on the landscape, and within a stand, both species are present in the overstory. So these two graphs are similar to the other ones, showing the basal area and trees per acre for the unharvested and previously harvested stands before the spruce beetle outbreak and after the spruce beetle outbreak in Engelmann spruce and aspen mixed stands. In terms of basal area, we observed only 45% of the basal area in unharvested stands and 66% of the basal area in previously harvested stands were killed. On a tree per acre basis, tree mortality was around 50%, leaving about 450 to 750 trees per acre not impacted. Now, when we look at the diameter distributions of pre and post beetle outbreak in unharvested stands, what we observed was that the beetle killed most of the spruce greater than 4 inches in diameter, that's shown in green in the bar chart, but left plenty of aspen to continue to occupy the sites. Another example of a diameter distribution in a previously harvested stand demonstrates that a similar pattern occurred. Most of the spruce trees greater than 4 inches in diameter were killed, leaving the aspen and some of the subalpine fir, which also is not a host for the spruce bark beetle. So when we look at the structural outcomes after salvage, we see a further reduction in live basal area and trees per acre compared to the unharvested and previously harvested stands, not to be expected. We observed basal area around 26 square feet per acre and trees per acre around 259. Now, when we break this down by species, what we see is the unharvested and previously harvested stands were dominated by aspen overstory, as seen by the basal area data, with abundant spruce and aspen in the advanced regeneration layer. Previously harvested stands were dominated mostly by spruce with some subalpine fir, and salvaged area had less overstory, but still had plenty of spruce and aspen. Looking at the regeneration species composition provides some good news again. Here we see that all Engelmann spruce is regenerating very well with densities that exceed minimum stocking requirements. Across the different treatments, most of the spruce had regenerated before the outbreak, so spruce that's greater than 5 years old. We also observed aspen regeneration is doing very well in all the treatments. Now, when we looked at the coal percentages in the spruce aspen mix stands, we also observed much lower percentages of less than 10%. Again, we were interested in understanding if the reduction in mature spruce trees would impact seed production and future spruce recruitment. And for this, we only had 2 years of data to measure seed production. And again, I wanted to just highlight that each bar is an individual year, and you can see how variable they are from year to year. However, seed production was similar among the different treatments within a year, indicating there's still a seed source close by. So to summarize some take-home messages, what we were seeing in spruce-dominated stands was the beetle epidemic had extremely high overstory mortality, but there was still an abundance of small diameter trees that were not susceptible to the bark beetle. In our unharvested stands, we had a spruce and aspen overstory with abundant spruce regeneration. The previously harvested stands were dominated mostly by spruce, and then the salvage stands were dominated by spruce and aspen. But the important thing to know, regeneration was happening and still exceeded the minimum targets for stocking. Now for spruce aspen stands, what we saw overstory mortality due to the beetles, 60%. In our unharvested stands, aspen was dominating the overstory, but there was an abundant small diameter and regeneration of spruce and aspen. In the previously harvested stands, was similar to the unharvested stands, but had more spruce. And then the salvage stands mostly was small diameter spruce, aspen, and fir. There was lots of aspen sprouting, and spruce regeneration is happening and still exceeded the minimum targets. And with that, I'd like to take any questions. Thank you for your attention and have a great day.